Good morning, dear students. This is the second lecture of sampling distribution. I will just have a small recap on the previous lecture. We have seen few terms over there. First one was population. Population is set under the consideration. Then we had sample. Sample means the subset. And then very important result we have proved when our population size is capital N, sample size is small n, then we had total, we can take NCN, total number of samples of size n, which will denote by K. And very important result, we have seen that whatever are these K samples, say S1, S2, Sk, will define a variable x bar which takes the values x1 bar, x2 bar up to xk bar. What are these x1 bar, x2 bar? These are mean of each sample. Then this x bar always follows normal distribution. X bar always follows normal distribution whose mean is mu and standard deviation is sigma upon root 10. And this result, whatever we saw in the previous video, that is called as sampling distribution. Now exactly what we are going to do. Again, I will continue with the same example we had seen in the previous video. Listen carefully. What we have to do is, say, the same example I am taking here. This is our class of 100 students. Class of 100 students means, of course, my capital N is 100. Now, exactly what we are going to do. What we are going to do is, as I said, we have marks of all these 100 students. Marks of all 100 students. And we are going to find the mean of these 100 students. Now you know very well, mean of this population is denoted by mu. So say I have mu is here. It is just some example to understand exactly what we are going to do. Mu is mean of marks of 100 students of the class. Now, actually there are two things. One thing is, I am going to pick up randomly some sample. As I said, we have picked up the sample of 10 students and we have asked marks to the 10 students. Say marks of 10 students are something 80, 82, 91, 85, etc. We have data of 10 students marks. Now, first thing is, one type is there that from this marks of 10 students, we can find mean marks of this entire class. I am repeating what I said. We have marks of these 10 students. We can always find mean of this sample. Say mean of this sample, what we are getting is 85, just as an example. Means we have mean of the sample. From this sample mean, we are trying to find what is the population mean. Means again I am telling you, we have marks of only 10 students where their mean. From the mean of this small set, we can try to find this mean of this entire population. We are going to estimate mean of the population, and that is actually estimation theory. Second part is, you will be given mean of this entire population. So mean marks are for this entire class, that is mu. I will give you, say mu equals to 90. This will be given to us, and what we are going to do is, in simple language I will say, we are just going to cross check whether this statement is right or wrong. Means we are not going to find value of mu. We are going to test whether this statement can be right or wrong. Simple, just a common sense I will say. If I have picked up this sample, whatever sample I had taken, I found their mean is say 85, 86, 87. Obviously mean of this small 10 objects, that cannot be equal to mean of this entire population, but it will be somewhere near to this value. Say I got here 85 and this is 90, so at least it is bit closer to 90. So we may conclude like yes, mu equal to 90 is possible. But if we are getting mean of sample is somewhere 40, then obviously what we will say, this 10 student mean is 40. How the population mean can be 90? So we may conclude that population mean equal to 90. This statement is false. Means in short, in non-mathematical language, usual daily language means I will just say we have to cross-check this statement is right or wrong. And in statistical language I will say we are cross-checking means we are testing this statement. Statement in a statistical statement is called as hypothesis. Any statistical statement is called as hypothesis. So we are cross-checking this statement means we are testing the hypothesis. And this is what we are going to have in this sampling distribution lectures. The previous video where I started, I wrote this heading. What we are going to see is testing of hypothesis. So understood, testing of hypothesis means again I am telling you, whatever is population mean that is given to us, we are just going to test whether this statement is right or wrong, means can this be a population mean. And the procedure for that is, we'll be having some sample and we are going to have mean of this sample. Say mean of the sample is close to 90, then we will say fine, this statement may be true. If it is not close to that value, we will say this, probably this statement is false. This is some simple non-mathematical things I told you. Now let's see how this result which I told you here, which I discussed in previous lecture also, and I said it is important how this result is going to help us. What I said, once again I am telling you, we have k number of samples and mean of each sample is x1 bar, x2 bar, xk bar. We are defining a variable x bar which takes these values. Then that variable follows normal distribution whose mean is mu and standard deviation is sigma upon root 10. Now how it will be used? Okay, actually how to use this result again we'll see in next video, but before that we need again some terms. So I'll define few terms and my first term is hypothesis. So just now I told you hypothesis means any statistical statement. Now, I'm sorry. In this hypothesis, we are going to have an again important thing what is called as null hypothesis. What is this null hypothesis? First of all, remember we are going to denote it by H naught. And this null hypothesis means it is the hypothesis, it is that statement which we are going to test. Say again, I will define all the terms with the help of this example so you will understand. Our example is we are going to check whether mu equal to 90, that is population mean equal to 90, is it true or false. We are going to test this statement. Whatever is this statement which we are going to test, that is called as null hypothesis, which is denoted by H naught. So null hypothesis, I will say it is the hypothesis which is to be tested. Simple example, I mean simple definition. Next we have alternate hypothesis. This we denote by H1 and we just see this is, it is the hypothesis which is complementary to H naught. which is complementary to H naught. What is the meaning of that? Meaning of this is, I will say, if our H naught is, what example I give you here, we have H naught is mu equal to 90. I showed you this. Our hypothesis, what we are checking is mu equal to 90. So obviously our H naught is mu equal to 90. Then this gives us our H1 is mu is not equal to 90. That's it. So alternate hypothesis means the hypothesis which is exactly complementary to H naught. Now next very important concept what we have to see is critical region and level of significance. This is the standard short form LOS. We'll discuss this and then we'll stop for this video. So again few basics will be clear, and in next video we can actually start testing the given hypothesis. So let's see what is the critical region and what is the level of significance. It's very important concept, so all of you pay attention. So again before defining it, actually I will give you the idea what exactly it is with the help of our example. Like what was our example? In our example, as I said, say we are given mu is 90 and this is the statement which we are cross checking. Means we know this is our H naught. And how we are going to cross check? We are going to have some sample mean. Means now understand this part. This is 90. What is the sample mean? Suppose my sample mean has come 89. Then I will say it's so close. I will say mu equal to 90 is correct. It is right statement. Even if it is 91, I will say it is right statement. Now one more term you have to understand. When I say this statement is right statement, means in statistical language we say H naught is accepted. Means we have tested this and our result is the statement is right. And when the statement is wrong, like now, suppose I am getting X bar as something 40. So what I will say, it's far away from this 90. So obviously I will say this statement is wrong. So that we write as H naught is rejected. Now I just made vague statement. When it should be when it is close to 90 we will accept. When it is far away from 90 it is rejected. But close and far away means what? There should be some fixed number. So suppose I have decided in between 85 to 95 means difference of 5. I will accept the hypothesis, else I will reject. Someone has decided in between 89 to 91 he will accept the hypothesis, else he will reject. So whatever is this region for the first person, in this region when X bar lies, we say hypothesis is rejected, and this region is called as critical region. Means where the hypothesis is rejected. Someone when says I am going to accept only for this, for him this much is the critical region. So critical region may change from person to person, and how we are going to put it mathematically, that is nothing but our level of significance. So right now you just try to understand. I will say critical region means it is that region in which when the test statistic lies, we reject our H naught. What is the meaning of test statistics? How it is defined? What actually critical region we are going to find? That again we'll see in next video. Now I just want you to understand critical region means the region in which when it lies, like here X bar above 95, I am going to reject the hypothesis. That is my critical region. For some other person maybe this is the critical region. So simple way now you understand critical region means The region in which when test statistics lies, we reject the hypothesis, we reject the H naught, that is the critical region, and LOS, that is level of significance, it is the probability of test statistics lying in critical region. So right now just remember these two things. Critical region means the region in which when the test statistics lies, we are going to reject the hypothesis, that's a critical region, and LOS, that is level of significance, that is a probability that the critical region, the variable lies in the critical region. Understand these two things, and the actual now mathematical meaning I will tell you in the immediate video. I am making very small video, just 15 to 18 minutes, because the topic is little heavier. So understand just these two definitions. Critical region means the region in which when the test statistics lies, we reject the hypothesis, and the probability of that lying in critical region is the level of significance. This just idea I have given you. Actual mathematical definitions we'll see in next video. So thank you and goodbye till then.